everyone. Today we are going to conduct the experiment number 4, measurement of dielectric strength. So here we have considered the three different materials like Teflon, ebonite as well as graphite in order to find out the dielectric constant value. So here you can observe this transparent one is called the Teflon, and this black color one represents, or we can call this as the graphite material, and the white color is actually the ebonite material. Okay, so here we are going to find out the permittivity of the dielectric materials. So dielectric relates to the permittivity of the material. The permittivity will be expressed its polarization to the applied field. So it is the ratio of the permittivity of the dielectric to the permittivity of the vacuum. So always the permittivity of the vacuum will be equal to 1. So let's start with the conduction of the experiment. So this is actually the experimental setup. So here first we are going to make use of the microwave test bench. First klystron power supply, klystron source, isolator and variable attenuator, frequency meter and slotted line carriage. So here first we are going to connect the detector. So then we are going to measure the D minimum. So means first minimum as well as the second minimum, and we'll take the difference. So then we'll replace the movable shot to the match termination to the movable shot without sample. So then after taking the V minimum, then we are going to insert the sample in the movable shot. Then we are going to measure the D minimum. Okay, let's start with the experiment. So here first we have generated the mode. So here this is actually the mode we are getting. So in this mode we are going to measure. We need to vary the slotted line in order to get the first two minimums. So this is actually the maximum voltage we are getting. So once we keep on moving, so this is actually the minimum we are getting. Yes, this is actually the first minima. So here is the first minima. So the first minimum value is 8.2. So next we are going to take the second minima. Second minima value is 10.5. So next we are going to find out this lambda g by 2. So first minima is equal to D minimum is minimum 1 is 8.2 minus 10.5. So once we calculate delta L, so we'll get the difference of the first minima as well as the second minima. We'll get delta L is equal to 2.3 centimeter. And once we find out that wavelength, so lambda g will be taken as 2 into delta L. So 2 into 2.3 is 2 into 2.3 is lambda g is equal to 4.6 centimeter. Okay, next we are going to replace the detector with the movable shot. So here you can observe the match terminator is replaced with a movable shot, and here we are getting the first minima. So here we are going to measure the distance of the first minima is 9.1. So we are going to write down that x1 is equal to, we'll consider that as x1 is 9.1 centimeter. Next we have to insert the ebonite into the movable shot. This is the movable shot with sample. Then we are going to connect it to the slotted line carriage. So once we connected with the movable shot with the sample, so next we are going to take the second minima. So just we have to move this slotted line carriage. So this is actually the second minima we are getting. So this is the second minima. So we have to find out the reading. The second minima is 10.4. So here we are taking the sample as ebonite and the second minima is 10.4. So then we have to do the calculation part. Delta L is equal to x2 minus x1, that is 10.4 minus 9.1 will get nearly 1.3 centimeter. 1.3 centimeter. So and A is actually the thickness. So this is actually the thickness of this distance. We need to consider thickness of the material. So here, sorry, a length of the material. So this is if we measure this, we'll get 2.3 centimeter. Okay, so and in order to find out the thickness, so here we need to put it on the movable shot with the vernier scale. So here we need to insert this and we need to rotate this in the screw gauge. So where exactly we'll get the thickness is nearly, so when once we move this, so we'll get 0.18. So by using this vernier scale, so we can find the value is 8.3. D is equal to 8.3 for the above. So for the ebonite, we are getting the scale in the where exactly these two lines coincide. So the value is 0.83. So the D value is 0.83 centimeter for the ebonite. Similarly, we'll continue the experiments. We'll follow the same procedure for the different materials. So the second one we'll going to consider Teflon. Okay, so the same procedure has to be followed. Next we are considering the second sample, Teflon. So first we are going to measure the length. So this is actually the length of the Teflon, that is 2.3 centimeter. So next we are going to find out the thickness. So once we inserted this into the movable shot, so then we are going to find the reading thickness. So here we are getting so nearly 7.4. Okay, 7.4, 0.74 centimeter is actually the thickness. So we have to write the D as 0.74 centimeter. 0.74 centimeter. So next we have connected this into this movable shot into the slotted line carriage in order to find out the second minima. Once we connected the Teflon is inserted into the movable shot and we connected that into the slotted line carriage, means we are getting the waveform. So and here the second minima is the actually this is actually the second minima. So the second minima value is 10.1. So 10.1 is the x2 value, 10.1 centimeter. So if we get 10.1 minus 9.1 means delta L we are going to get 1 centimeter. Okay, 1.0. Okay. So next the same procedure will be followed for the graphite also. So if we repeat the same procedure for the material graphite, so here we need to measure the length, that is 2.3 centimeter. So next we need to find out the thickness. So thickness once we find by using the vernier movable shot, means the D we are going to get it as 0.84 centimeter. Okay, so then if we observe if we insert this graphite into the movable shot and connect it to the slotted line carriage, means we are going to find the second minima. So here you can observe this is actually the second minima we are getting. So and we'll find out the reading. So we'll get 11.2. So 11.2 is the x2 value, second minima value, 11.2 centimeter. In order to find out this delta L, 11.2 minus 9.1. We'll get 2.1 centimeter as the delta value. Okay, once we take all the readings, we need to make use of this formula. Tan x by x is equal to lambda g divided by 2 pi d into tan of 2 pi by lambda into delta L plus d. Okay, by using this formula, we are going to calculate So once we calculate this for the ebonite, we'll get tan x by x. So we'll get minus 0.3229. So in order to find out the x value from the tan x by x, we need to make use of this table. Permittivity distributed circuits will be having the values for tan x by x and the corresponding x value. We need to see the table here. So for that particular value, minus 0.322. So here we'll get the value as uh, 0.322339 near value we are getting. So the corresponding value is near value is 0.332, near value is 2.455. Okay, so 2.45 is the x value here. Okay, similarly we have to calculate for Teflon. For the Teflon, tan x by x minus 1.311y, x value we are getting 1.945. Similarly for the graphite also, tan x by x is equal to 1.632, x value we are going to get 1.040. And once we get all the x values, we need to find out the permittivity. So permittivity formula is epsilon is equal to x by pi whole square into x by d plus 1 divided by 2a by lambda g plus 1. Okay, so if we substitute the values of, once we substitute all the values to this formula, so we are going to get the epsilon is equal to 2.908 for the Teflon, and for the graphite epsilon we are going to get 2.803, and for the ebonite epsilon is equal to 3.03. Okay, thank you girls.